Happy Thursday, everybody. It's Mr. Markward again, rolling with you through 4.2.3. We're solving systems of equations using elimination. Looking forward to jumping into that in just a second here. I hope you guys are having a great day so far. A couple announcements. So we have homework collection number 4 is posted today. So please make sure you check It's Learning at some point throughout the day and get those homework pictures up to date. Again, remember, homework is not optional. Again, that's 15% of our grade for the semester. So you got to make sure you keep up with that, or you're just doing nothing but hurting yourself in the long run. And we certainly do not want that. So other than that, we're about 2/3 of the way done with chapter 4. We have one more week of lessons next week. Then we start chapter 5 the week after, and we've got our test that following week. So that's coming up pretty quick. So I hope you were keeping up with all of our homework, all the quizzes, the chapter 3B test. Again, there's been a lot of stuff happening in Algebra 1 so far since the second semester has started, so hopefully you're keeping up. If you have any questions or concerns with that as you are going through and trying to get caught up if you are behind, please make sure you reach out to your grading teacher and let us know. We are always more than happy to help you all. Just got to make sure you are taking the initiative and reaching out to us. We can't read your mind and know that you're struggling unless you tell us. So please make sure that you take advantage of that. Reach out to us. We're always happy to help you all. So that being said, we're going to first flash those homework answers up really quickly because you can pause the video. Then we're going to jump into 4.2.3 solving systems with elimination. So there we go. Homework answers. Pause that video. That's all we got. Moving on. We're going to start with a little warm-up question today. So we have a system of equations is graphed at the left. We got those two lines. What is the solution to the system? So if we think back to our Chapter 4 toolkits, hopefully we have those out in front of us anyways, we know that the solution of a system of equations on a graph is always where they intersect, where those two lines intersect. So I don't see any intersection point here. In fact, if I'm looking at the slope, we're going down 1 over 2 for that red line. The slope for the blue line is down 1 over 2. So our slope again is minus a half. And I'm not sure if we talked about this a whole lot in chapter 2, but I know we did mention it. If two lines have the exact same slope with different y-intercepts, they are parallel. Parallel lines never ever cross. So for this one, our answer should be no solution because the intersection of a system of equations is always a solution. Here there's no intersection, so there's no solution. Good little way to get our brains thinking this morning. Next, let's jump right into 4.2.3 and look at 455. So we've so far talked about two different ways that we can solve a system. First being the equal values method. That's if we've got two equations equal to the same thing. We've seen that most frequently with things being in slope-intercept form so far, where it's like y equals something and then y equals something. And if two things are equal to the same thing, they're equal to each other. And then you can solve for x and so on and so forth from there. We also learned how to do substitution on Tuesday, which is again when we have one variable isolated by itself, we can take whatever that variable is equal to and plug it into the other equation and then solve for that variable. So we'll have one equation with one variable, and that's a whole lot more friendly to us. And again, hopefully that stuff is pretty easy at this point for us. So today, learning one new method, elimination, and we're going to talk about why we need another method here first. So personally, I think elimination is one of the best ways we can solve by a system of equations because we don't always have to solve for a variable, because sometimes that can be pretty tricky. We can get some messy looking fractions, and the substitution or equal values method might not be the best way that we can solve for that system. So if we look at 55, we're trying to show that exact same thing. So right now we want to solve this system of equations with substitution. So let's take a look here. We got 3y plus 2x is equal to -2. And then our second equation is minus 3y plus 5x is equal to 16. So the first thing we want to do is we want to solve one of these equations for y. I just kind of randomly picked the top one just because y is already positive. That would be one less thing to change at the end. So I chose to solve that top one for y. And when we do that, we get this whole jumbled mess of stuff here in red. So the reason, let's walk our way through here. So we have that red equation, 3y plus 2x is equal to -2. If we're trying to solve that one for y, so we can use substitution, first thing we're going to do is, again, move 2x over from the left to the right. Then we have to divide everything by 3, which gets us some kind of messy looking fractions here. So we got y is equal to minus 2x divided by 3, all minus 2 over 3. So this is what we got to plug in for y in our second equation. Again, our second equation is minus 3y plus 5x is equal to 16. So when we plug our value for y in here to our second equation in blue, we would get negative 3 times negative 2x over 3 minus 2 over 3, that whole quantity, and then we're adding 5x to it. That's still all equal to 16. A lot of stuff happening here, a lot of fractions. So again, hopefully whenever we see a number outside of a set of parentheses, our first instinct is going to be to distribute that number along with its sign into both terms inside of those parentheses. So we would get 6x over 3 plus 6 over 3, because again, we multiply the numerators together, leave the denominators, especially because that negative 3 is really like negative 3 over 1. So then we can simplify both of these fractions, because 6 divided by 3 is 2. We get 2x plus 2 plus 5x is equal to 16. And now we can finally solve for x, and if we work that all the way through, we get x is equal to 2. So after all that work, we're only halfway there, because we still got to find what y is equal to. So now we can take our value for x, plug it back into our equation that we know what y is equal to. So when we plug in 2, we get negative 2 times 2 divided by 3 minus 2 over 3. So we get negative 4 over 3 minus 2 over 3. So that's minus 6 over 3 because we have common denominators. We subtract the numerators there. And then if we simplify that, we get y to equal negative 2. So whenever we have x and y for our variables, we always want to finish as an ordered pair. So that first answer should be 2, negative 2. So that's a lot going on there. Again, a lot of fractions, really messy, really easy to make mistakes when there's fractions. So we want to find a way where we can get rid of those fractions. And let's see if we can find a better way, because that seems really messy.
There's got to be a better way.
Now there is.
So we want to now look at the next page, 456 part D. We want to look at that same system of equations, and we want to solve by something called elimination. So basically the key to this is when we see the same two sets of equations, we kind of want to add these two together vertically. So we want to combine add like the old school ways, up and down, adding the like terms together, and we're looking for an opposite, or like a pair of opposites with a variable. So for example, we've got 3 and negative 3 right here, because if we add 3 and negative 3 together, that gets 0. So if we get 0 times a variable, we're always going to get 0. So we're going to get one term to cancel for sure when we add these two together. So what we want to do when we solve by elimination is, again, add up and down, add the same terms, or the terms of the same variable, so the y's, the x's, the constants together. So when we add these two together to solve by elimination, we get 0y plus 2x plus 7 or plus 5x is going to get us 7x. The equal sign stays where it is. On the other side of the equal sign, we have negative 2 plus 16, so we get 14. So then our 0y, again, that's 0 times y, so that just goes away. So we are left with 7x is equal to 14. And now all we have to do is solve for x. That's pretty easy, I think. We just got to divide by 7 on both sides. So that means our solution for x is equal to 2. So if you ask me, that's a heck of a lot faster than what we did on the last page, where we had to solve for y first and then plug y in for, or plug that whatever we got for y into the second equation, then solve all that through for x. That seems, this method of elimination seems a heck of a lot faster than that. So let's now find our solution for y. So we can take this value for x, we can take it, plug it back into one of our equations up here. Let's just pick the top one, for example. So now we've got, we'll do that over here in red, we've got 3 times y plus 2 times 2, because x is equal to 2, is equal to negative 2. Once we evaluate this, 3y stays the same for the time being. We're going to add 4. That's still equal to negative 2. We got to move this 4 from the left to the right because we're solving for y, so we're going to subtract 4 from both sides. And let's see here. Where do we go from here? So the 4's cancel. Now we've got, I'm going to move this up to the right. 3y is equal to -6. Last thing we got to do is divide by 3, divide by 3. So y is equal to -2. And again, if we think back to the first part where we tried to solve that one by substitution, again, doable. We get the exact same solution of 2, -2. Just we did a lot less work to get the exact same thing, solving by elimination. Again, we just add the like terms together vertically in our system of equations. So again, if we think back to how to solve, or not solve, but if we think back to how to check to make sure our solution is accurate, what we do is, if we ask the Glade plug-in jingle, plug it in. We plug it in, right? We plug it in. So we take both equations. So we have 3y plus 2x minus equals -2. Our second equation is minus 3y plus 5x is equal to 16. Knowing again that our answer as an ordered pair was 2, -2, we can plug in our answer and then solve. And if both sides of our equal sign are the same, then we know we did our job correctly. So let's do that. We've got 3 times -2, because -2 is y, plus 2 times 2 is equal to -2. So now when we evaluate this, we got -6 plus 4 equals -2. So -6 plus 4 is -2 equals -2. So far, so good. Do the same thing on the right-hand side. -3 times -2 plus 5 times 2 is equal to 16. Negative times a negative is always a positive, so this turns to +6. Plus 5 times 2 is 10, is equal to 16, which is indeed a true statement because 6 plus 10 is 16, is equal to 16. So we are good to go. We solved that system correctly with elimination. So let's try another one together here. Go to the top of the next page, 56F. 56X, we're going to take 56F, sorry. We're going to take both of these equations and we are going to solve by elimination one more time. So I'm going to first rewrite these. Our top equation, 2x minus y is equal to -2 minus 2x plus 3y is equal to +10. So again, we're looking for things that are going to cancel if we add these two things together. If we add these two equations together, we're looking for stuff that's going to cancel. And I think looking at these two equations, if we add 2x and -2x together, those two things are going to cancel. Because 2 plus -2 gets us 0, and that's what we're looking for. So let's add these two things together. Again, we're eliminating that variable of x. So we're going to add both of these equations together. 2x plus -2x is 0x. We have -y and then positive 3y. If we add those together, we're going to get plus 2y is equal to 10, or -2 adding 10 to that is going to be +8. So then that 0x goes away, so our equation is 2y equal to 8, and then now we just got to divide by 2 to solve for y, and y is equal to 4. So one more step, we got to find x. We got to find x, and again, how do we do that? Plug it in, plug it in. So we take that y and we plug it in to one of our other equations. Let's plug it into this top one. I'm going to rewrite that off to the right-hand side over here in red. So we've got 2x minus y is equal to 4 is equal to -2. So first things we got to do is add 4 to solve for x. Add 4, so we get 2x is equal to +2. Then we divide by 2. Divide by 2. X is equal to 1. So our final answer here is 1, 4, and we solved that systems of equations. So for the sake of time, we're not going to check this one, but again, if we want to check this, all we got to do is plug it in to both equations up on the top, and both sides of our equal sign should be exactly equal to each other. Alrighty, so hey, let's go on to 57. 57, we've got Pat's at a fishing competition at Lake Pisces. He caught some bass and some trout. Each bass weighed 3 pounds. Each trout weighed a pound. Pat caught a total of 30 pounds of fish. He got 5 points in the competition for bass. And since trout are endangered in Lake Pisces, he lost a point for every trout that he caught. So he scored a total of 42 points. So again, we want to look at the things in these sentences that are talking about the exact same things. We've got weight for one thing, and then we've got another sentence talking about points. So I think we need to write an equation for both. One equation for points, one equation for the pounds of fish. So again, let's go back through and highlight those. Each bass weighed 3 pounds. Each trout weighed 1 pound for a total of 30 pounds of fish. The points we'll do in green. He got 7 points, or 5 points for each bass. Since trout are endangered, he lost a point for each trout. He's got a total of 42 points. So we need two equations. So again, let's first assign our variables. Let's let B equal the number of bass. And then we're going to let T equal the number of trout. Alrighty, so now let's write a couple equations with those two variables. Again, B and T seem pretty intuitive since we have bass and trout. So let's start with our yellow one. We've got 30 pounds. Oh, come on, 30 pounds. Let's do that. The yellow one is going to be in blue. So again, our total is going to be 30. We have 3 pounds per bass. So that's going to probably be the number of bass times 3 for 3 pounds per bass. And then we're going to be adding 1 pound per trout. That seems like a pretty good start. Our second equation is with points. Again, we have 42 total points. He got 5 points per bass, and then he lost 1 point per trout. And let's see if this is going to be a good candidate for the elimination method. So there's our two equations. We're going to go to part B here in just a second. So is this a good candidate for the elimination method? Let's figure out if it is or not. So again, let's write these things on top of each other. That might make it a little easier to see. So we have 30 equals 3b plus 1t. Then we have 42 is equal to 5b minus 1t. So again, we're looking for things that could offset if we add these things together or cancel out. So if we look for things that might cancel out, I think we're going to get this positive 1t and negative 1t to cancel. If we add them together, we'll get 0 t's left. But everything else we can add together just fine. So when we add these two together, we will get 72 is equal to 8 times b. And again, we have 0 t's left. So that just kind of goes away. But we have 72 is equal to 8b. So we're going to solve this. That'll tell us how many bass we have. So 72 is equal to 8b. So to get b by itself, we got to divide both sides by 8. 8's cancel here, so we get 9 is equal to the number of bass. And again, if we want to find the number of trout next that we caught, now we got to figure out, or now what we're going to do is take this 9, plug it in for b into one of our two equations. Let's just pick the top one. And when we do that, I'm going to write it down here in green. We have 30 is equal to 3 times 9, which is the number of bass, plus our 1t, which is going to tell us that we have 3 times 9, 30 is equal to 27 plus t. So to get t by itself, we got to subtract 27 from both sides. And we're left with 3 is equal to t. So we get 3 bass, 3 trout for this fishing competition. And that is how he did, or how many fish he caught of each. So one more thing we're going to talk about today in the video is number 58. Number 58, we want to figure out if we can use the elimination method with this one. So we've got 2x plus 7y is equal to 13. Then we have 2x plus 7y is equal to 5. And again, we're looking for something that could help us cancel a term. So if we look here, we've got 2x and 2x. We got 2x and 2x. Let's see here. That would be really nice if one of those was negative, wouldn't it? Because then we would have a way that if we added those together that those things would cancel. But I think we can maybe make that negative. And there's a way we can do that. So if we have two of the same variables, so 2x and 2x, we need to make one of them negative so they cancel each other out. So let's multiply this bottom equation, that entire bottom equation, by -1. So if we multiply everything in there by -1, again, we're not changing the value of the system at all. We're just making it easier to solve. All we're doing is changing the sign of this one. We're not changing anything else. We can use that to help us solve this system. So if we multiply everything in here by -1, the top one stays the same as 2x. I'm going to put that down here. 2x plus 7y is equal to 13. And then we got to distribute this -1 to every single term in the bottom of the equation because we want to change that sign. So these first two terms are going to offset. So we get minus 2x minus 3y is equal to -5. So now we can do our elimination method where we just add the like terms up and down, where we get 2x plus -2x is going to be 0 x's, so those cancel out. We get 7 plus a -3y, which is like subtraction, so we get plus 4y is equal to 13 minus 5 is 8. So again, the x goes away because we canceled those out. So we're left with 4y is equal to 8. I'm going to write this off to the side here. 4y is equal to 8. To solve for y, now we just got to divide by 4. Divide by 4. Our 4's cancel on the left. Y should be equal to 2. And then last but not least, we got to plug that back in. Plug it in, up into one of these equations. Again, I'll just pick the top one so we can solve for x. Let's do that in red down here. So next we have 2x plus 7 times our y value, which is 2, is equal to 13. Perfect. So 2x is or 2x plus 7 times 2 is 14 is equal to 13. Now to get x by itself, we got to subtract 14 from both sides. Subtract 14, subtract 14. The 14's cancel on the left. 2x is equal to -1. Last thing, divide by 2, divide by 2. And again, that means if we go off to the side here, that x is equal to -1/2. So we got an x and a y. We should always write our answer as an ordered pair. So final solution here, x is -1/2, y is 2, and this is what we get. All right, folks, so we're going to stop there for today. I would recommend that you do 59 on your own. I'll fill these out for us for the filled in notes. Good practice as well with a new concept. A little hint as you're working through this one, rearrange one of the two equations so the like terms are lining up. So rearrange part B, rearrange one equation so we have the like terms on top of each other. So like either move this top one so the x's are in a row or the y's are out front, just kind of whatever makes it easier for you. So we want it to look something more like A instead. So we got to rearrange one of those two equations. That's my hint for part B. Again, check the filled in notes for those answers for this one. Otherwise, the homework for tonight, everybody, is 4.2.3. Make sure you check the homework collection number 4 on its learning today. Otherwise, hope you all have a fantastic weekend, and we'll see you all next week. Bye, everybody.